So in this video, we'll talk about what does it really mean by the slope of a line, or the variable m that we associate when writing the equation of the line y equals mx plus c, or something like y minus y1 equals m, well, x minus x1, or something like that. So what does it really mean by the slope? We define m, or the gradient of the slope, initially as the steepness, or how steep a line is. And that is to say that if you have two lines like this and like this, we know for just by the conceptual definition of the term m that this has a greater m value and this has a smaller m value. So this could be something like m equal to 3, and this could be something like m equal to 1, right? So if the line goes steeper and steeper, if it climbs really quickly with respect to the movement along the x direction, that is, if you are a person who is trying to go in the direction in which the line heads, you would find it harder to climb this line than you would do to go along this line. And we have defined m to be equal to something which measures the ratio of the distances in the y direction and the x direction. So what does it really mean by this ratio? If you remember, and here's the diagram again, we had 2 points separated by some amount of distance in the y and the x directions. So if this is a line with a slope m, this was supposed to be our spacing in terms of the x coordinate, and this was our spacing in terms of the y coordinate. By that definition, we had m to be the ratio of this divided by this. And if you notice that since delta y and delta x are parallel to the y and the x-axis, this angle here is a 90 degree. And if it's a 90 degree, which is the same logic we used when we were calculating the distance between 2 points, A and B, if it's a 90 degree, then we can use the rules of trigonometry very easily. So with respect to this angle, theta, right here, that is the angle that the line makes with respect to the x-axis, we can define tangent of that theta to be equal to the perpendicular by the base in a right angle triangle. And we can see very easily that the perpendicular is nothing but the delta y value, and the base is nothing but the delta x value. So it turns out that tangent of theta is what we have been measuring all along, and what we have been calling the value m, or the slope of the line. So if you're given a line and you're told that the line makes an angle of 30 degrees from the positive x direction, then the slope of the line will always be tangent of 30. And tangent of 30 turns out to be 1 over root 3. So that's a value smaller than 1. And now we can apply this logic to lines which are perpendicular to the x-axis and lines which are parallel to the x-axis. So let us take these two cases individually. In the first case, when the line is perpendicular to the x-axis, we know that the angle that it makes with respect to the x-axis is 90. So in that case, m should be tangent of 90, and tangent of 90 is infinity. So the slope of this line is infinity. That is, it's impossible for you to climb the line, because it's the steepest that you can possibly be. And for a line like so here, the angle that it makes with respect to the x-axis is actually 0. So for this line, m is tangent of 0 degrees, which is 0 if you look up in the trigonometric tables or something like that. So this line is very easy to climb because the slope is 0. And it makes sense by the numerical values of m. And by this, we have shown that if we go from the horizontal to the vertical, the slope gradually increases until it reaches the value infinity. So with all that in mind, now that we have established that tangent of theta is what we have been measuring as the slope or the gradient of a line, we can work out a few examples. Again, let us have our axes like so, the y-axis up there, the x-axis down there, and say we have a line that goes like so. So there are 2 questions at this point. If this height is c and the slope of the line is m, then what's the equation of the line? The equation of the line, as we have discussed earlier, is y equals the slope, which is m, multiplied by the intercept, or multiplied by x, added to the intercept that the line makes with the y-axis. Now the intercept here is the distance at which it cuts the y-axis. And since we know that that's c, we just need to substitute c there. So we are back to the same equation of y equals mx plus c. That's cool, so we know that. Now, say I tell you that this angle right there is 135 degrees. And this angle here has to be 180 minus 135 because this whole angle is 180. So that should be 45 right there. Now I ask you, all right, so if I have given you a line that makes 135 from the positive x-axis, could you tell me what the slope of the line is? Now in this case, we have two angles to consider, 45 or 135. That is, should M be tangent of 135 degrees or should M be tangent of 45 degrees? That's the question. To answer that, we need to look back at what we had done with the previous examples. In a previous example, we were always measuring the angle with respect to the positive x-axis. So we always measure the angle starting from here, going towards the line. So by the same logic, if we start from the positive x-axis and go down to the line, wherever it cuts, that should be the angle that we should be considering, not the angle that starts from the negative x direction. So we don't call the slope to be tangent of 45. The tangent of 135 is, if you would have guessed it, let me just work that out, is -1, which makes sense. So the slope of lines that actually go downwards, that actually, for a person who is actually traveling along the line, that person might actually find it easier rather than having experiencing any sort of hardness to even travel that distance. It would be really easy for the person to actually go down because the person would be actually going along gravity. Now that's another, that's a topic for another video, but the sense that you can make at this point is, if the line is vertical at this point, let's say this, then the slope is 0. If the line is something like this, where the angle theta is somewhere between 0 to 90 degrees, the slope is between 0 and 1. 0 and infinity, sorry. If the line is absolutely perpendicular, something like so, then M is infinity, because the angle that it makes is 90. And if the line is sort of making an angle more than 90 degrees, oh, that's a very dark line. If the line makes an angle more than 90 degrees, something like this, then M actually takes all the negative values, so M is less than 0 in those cases. So that's it. You now know the ranges of M. M is 0 to start with, if the line is going this direction. Then as you increase the angle with which the line forms with the x-axis, the M starts to take values greater than 0, which is greater than this value, and goes all the way to infinity. It reaches infinity when the line actually makes 90 degrees with respect to the x-axis. And if it even crosses that threshold, it further makes the value of M to be negative. And that is what we find here. So when it's making an angle, say 135, M turns out to be a negative value, which we didn't encounter so far. We were always dealing with values of M between 0 and infinity, so they were all positive. And that's how it goes.